Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled PK 164 plus 31.1, the Headphone Nebula. So what do we see here? Well, here we see what is commonly known as the Headphone Nebula. So a more modern take on some of the objects that we see in the sky there. It's also known by catalog designations of PK 164 plus 31.1 or Jones-Emberson 1. Now, those are its names, but what is it? This is actually what is known as a planetary nebula. Now, a planetary nebula is the end of the life of a star, much like our own sun. In fact, it's the end state of most stars in the universe. Almost every star will go through a planetary nebula phase toward the end of its life. This is when the star runs out of fuel. And as the core runs out of fuel, it has no energy production, so it starts to contract down and get smaller and smaller. But while the core contracts, the outer layers expand outward, and eventually they become so large and so distant from the rest of the star that any instabilities can cause them to be expelled out into space. And that's what we're seeing here. The central star is now what is known as a white dwarf, the compact core of the original star here. The outer layers are the outer regions of that star that are now expelled out into space. So in a way, the star just gets larger and larger, in this case covering a very large chunk of the sky, apparently. In fact, about 1/5 the diameter of the full moon. Now you might wonder, if it's that big, why can't we see it? And it's because it's so faint. The light is spread out over a much larger area, and you need a proper instrumentation like a telescope to be able to actually pick it up with the longer exposure. Now, the coloring is actually looking at the hydrogen and oxygen emission. So there's a reddish color for hydrogen, a bluish color for oxygen. And those are gases that are excited by the star at the center. That white dwarf star is extremely hot, tens of thousands of degrees, much hotter than our sun, and emits a lot of ultraviolet light. The ultraviolet light ionizes the atoms around the gases around it, and then they glow. So it's energizing those atoms, causing the glow that we see here. Now, while it happens to a lot of stars, it's a very short-lived phase compared to the other phases of the life of a star like our sun. In this case, this might last tens of thousands of years, much shorter than the billion-of-year lifespan, 10 billion year lifespan of our sun. So while it is a very short phase, it's also one that we get to see prominently as a nebula, and something that some distant astronomer looking back towards our solar system in 6 billion years or so might see our own sun looking like. Now, the exact structure depends on the nature of the star itself. And in some oddly shaped ones like this, it's thought that there is another star or larger planet there that might be affecting the distribution of the material. So the exact nature of each planetary nebula is unique to the system that forms it. So that was our picture of the day, titled PK 164 plus 31.1, the Headphone Nebula. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.